We're going to try and talk about these aspects of the function generator and how they work. All right? So this is a function generator. So the basics. First, there's three BNC connectors, as they're called, coaxial connectors. Notice this one's an input. This is for something that we're not going to use right now, and this is the output. When you're using this, make sure you connect the cable to the output. So it's got one of these little, you put it in and then you twist it. So I'm going to slide it into here, and then I twist it and it snaps on. Now the output is going to be right here, and so I can just clip this to any circuit just like a battery. What's cool is the function generator can apply different types of signals. You can do sine waves, square waves, or triangle waves, and there's other things you can do in theory, but let's leave it at that for now. So first I'm going to turn it on. Okay, and notice it's not doing anything. That's because I have yet to select a range. So how do these ranges work? This means select a frequency up to 5 hertz. Let me get a pointer here. This means up to 50 hertz. This is up to 500, and then 5K, 5 kilo. So this would be up to 5,000, up to 50,000, 500,000, 5 million. You can invert it if you need to. So let's just pick something right here. So when I click this button, notice over here, this is 2,787 hertz. Whereas if I click this other button, it's 275 kilohertz. Notice the light here is on kilohertz. So that makes sense because this goes up to 500. Notice when I turn this all the way down, it doesn't go to 0. So this ranges from about 40 kilohertz up to about 500 kilohertz. So that's why it says up to. And notice, well, wait, what if I need something under 50 kilohertz? Well, I click on this range, and notice the upper limit of this one overlaps with the lower limit of that one, etc. So this goes from 53 kilo down to about 4 kilo, etc. So that's how you can adjust the frequency, the range. And these two buttons over here, now we're back to 414 hertz. This is the coarse frequency adjust. So it makes large changes. Notice there's a lot of lag, right? As I turn this dial, it takes it a second to respond. And so the fine gets you a finer adjust, so you can adjust by small increments. Usually what I do is I put both of these at the 12 o'clock position, and then it's very quick to coarse adjust to approximately the right frequency, and then fine adjust. Let's get this right at 4K. Notice I just pause for a second. Very small adjustments here, tiny fractions of a turn. And so you can dial in whatever frequency you want there. It's never perfect. What does this look like? Oh, this set of knobs we will not use. Now, you've got to be careful. If they're pressed in, this is going to cause trouble. All right? These are going to cause trouble if they're pressed in, so you want them not depressed. This minus 20 dB basically just mutes the signal. Sometimes that's useful. We may actually use that. But notice this way over here, this knob that says output level, this is all the way down, this is all the way up. Just like the frequency, it never really turns off completely. So if you couldn't get the signal low enough for your needs, that's when you would use the minus 20 dB. DC offset, all that does is it adds or subtracts a certain voltage to the entire waveform, shifts it up or down, and that's what that does. These we don't need. Again, so let's click the sine wave. So now I have a sine wave at about 4,000 hertz. Let me get that going there. Close enough. Whoops. You can see how sensitive it is. We'll leave it at this. So it's a sine wave at about 4,000 hertz. And this is the output. And if we want to look at this, I'll take it over to here. And now I have that across this resistor. Well, how can we see it? Okay, so I just connected one side to each of the resistor. We don't even need the breadboard. You could take the breadboard out of there if you really wanted to. As I just broke this resistor here, maybe. There we go. So you don't even need this. You could just connect it right here. Right like that. Okay. And now I want to measure it with this oscilloscope. So I just checked that this was roughly calibrated. It is. And this is a little bit confusing. The way the scope works, this is the black lead of the scope, and it's connected to the ground in the wall socket. This is actually the red lead. Similarly here, this red lead is connected to the wall, this black lead is connected to ground at the wall socket. So that I don't get a ground loop error, I'm going to connect the two blacks together and the two reds together. And notice I just push on this to make the little hook come out. Try not to mess these up. They're like 50 bucks each or something. I don't know, maybe they're cheaper these days. Now look at the screen. I don't know if you can tell, but I've got this set up. The screen is measuring approximately, if I could point right here, it's measuring about a 2 volt peak-to-peak sine wave at 4,000 hertz. There's the period, the max and the min are both there. And then Angus, if you could show this at the same time as that. So now what I'm going to do, I'm going to change the frequency, and hopefully you can watch this. I'm going to click the auto range off, that way it doesn't change. If I change this frequency, at a lower frequency, we see fewer bumps per screen. At a higher frequency, let's even jack this way up. So now I'm at 9 kilo, we're going up here, 15 kilo, we see the bumps occur much more rapidly here. In the next video, I'll explain how you can adjust the scope to really understand this. All right, and then one last thing, the output level, just to be clear, notice that if I turn up the output level up or down, you can see it going up, and if I put the minus 20 dB, give it a second. Oh, it's so small now. Have to hit auto range again. You can see it's there, but if I look at the measurements now, it's much lower. It's millivolts instead of volts. That's it.